In the future, most urban areas may develop into smart cities, which are connected, sensory, and data-fueled. Drones and UAVs will become more prevalent in smart cities for commercial, research, and other purposes. However, they also come with their own challenges and problems, such as natural disaster control. At present, the average response time to a fire is 8 minutes and 49 seconds in urban areas, and this value is increasing every year. However, UAVs could be applied to help mitigate this and aid the emergency services in tackling fire and flood disasters. With regards to requirements, the UAV will need to provide a live video feed to the operator, giving them an understanding of the situation before they arrive, saving precious time. The operator must be able to keep track of the UAV and be able to monitor the severity of the disaster as well. For ease of use, a low stall speed would be preferable to allow for lower speeds during monitoring. In order to meet these requirements, certain payload will be necessary: a video camera that enables live video footage to be viewed by the operator, and a thermal imaging camera to monitor the severity of the fire and its direction of spread. The UAV will also contain a GPS module so the operator will know its location at all times. The initial design phase includes producing a design tool spreadsheet which will be used to size our UAV and produce important parameters. Using inputs which are derived from the requirements of the UAV, the importance of the spreadsheet, using Microsoft Excel, is reflected through the construction phase as the important data obtained such as dimensions and constraint diagrams provides an initial design of the UAV that will fly and work for our application. The dimensions and sizing of the aircraft, as well as the initial design ideas obtained through the design spreadsheet, will be used to produce CAD drawings in SOLIDWORKS. These drawings will then be used to produce the fuselage and wings using laser cutting and hot wiring machines, respectively. The material used for the fuselage was 3mm or 1.5mm plywood, whereas expanded polystyrene or EPS was used to produce the wings, and carbon fiber rods are used to join the fuselage with the tail. After the first iteration, the UAV was bigger than expected, but allowed the team to understand the design and building process, as well as applying all the electronics. This is the first practice flight test. This practice test was an indication that the UAV was stable. However, a heavy landing caused some damage to control surfaces due to the UAV being too heavy. For the official flight test, we attempted to incorporate thrust generation during flight. In flight test 1, the UAV landed heavy due to a negative wing setting angle. This was a construction error which compromised the flight performance. Also, the fuselage structure was too bulky, which contributed to the excessive UAV weight and blocked the oncoming air, reducing the amount of thrust generated from the propeller. The UAV sustained considerable damage and the tail was not secured in place effectively prior to the test, which resulted in twisting of the tail rod that caused some instability. From the previous flight test, we ensured the fuselage size was significantly reduced to give the propeller some space and in turn reduced UAV weight. Also, the aspect ratio was increased to improve performance and the 2 tail rods were used. Our UAV enables precise live monitoring of a fire or flooding event before they reach its location. This saves precious time and allows the responders to act quicker, increasing the chances of lives being saved while also reducing property damage. The UAV incorporates a simple configuration which is cost effective and easy to manufacture using common processes such as laser cutting and hot wiring. Additionally, the design is easily constructed and operated on site with minimum requirement for training or expertise. The UAV has a high aspect ratio to enhance lift, generation and glide capability with a lowered operating mass. The unassembled size allows the user to transport between sites with almost no difficulty. The thermal camera allows firefighters to understand the severity of the fire, as well as its direction and speed of spread, while also helping with spotting people through smoke or low visibility areas. This project allowed us to understand some of the challenges that come with designing and building a UAV. Often several issues incurred due to our lack of experience caused changes in the UAV design, such as including a door in the fuselage roof to allow access to the payload and electronics, and incorporating 2 rods for the tail to reduce the twisting motion. However, one of the major challenges was time management, as there was a time constraint on getting parts from the laser cutting and hot wiring machines, so building each iteration of the design took much longer than initially predicted. Moreover, several compromises were made. As the tail was the part of the UAV that required replacements most often, we switched from using foam board and hand making the tail wings in order to save time. However, this reduced accuracy in the shape of the airfoil. Additionally, a trade-off between the structural integrity of the fuselage and its mass resulted in a lighter fuselage, but consequently it was much weaker. One of the major lessons we have learned is in regard to time management, which is an important aspect in our project. When something goes wrong and a replacement part is needed, as there can be problems with getting the correct parts due to technical or human error, this has taught us to construct contingency plans in unforeseen circumstances that may delay the manufacturing or testing process, and to organise ourselves so that our time is used efficiently. The team has gained valuable experience with the engineering design process, and the iterative fashion employed to obtain an optimized solution. This method required efficient group communication to keep everyone updated with all the modifications made. All teammates' contributions and their respective roles are highlighted in the table shown. Overall, this design module has been valuable for our learning experience and will allow us to apply our improved skills and knowledge when working on future projects.